Okay, welcome to our lesson on surface area and volume of prisms. So far in our area unit, we've been dealing with two-dimensional figures. Now we're going to start dealing with three-dimensional figures. So we already know the basic area formulas for things like squares, circles, rectangles. Now we're going to move on to prisms. So there are three different formulas for each type of shape that we'll deal with. One will be the lateral surface area, one will be the total surface area, and one will be the volume. So you have access to the formula chart. Depending on the type of shape it is, you'll make sure that you're using the correct formula and the correct area or volume that they're asking for. So our equation here for lateral surface area of a prism is LA equals capital P times little h. So capital P, you'll see down here listed below, is defined as the perimeter of the base, and h is defined as the height, or we're going to really talk about it being the distance between the two bases when you have a three-dimensional figure. Total surface area, that equation is SA equals the lateral surface area, which was capital P little h, plus 2 times the area of the base, which is a capital B there. So you'll notice there below it says capital B stands for the area of the base. And then our last formula is for the volume. The volume equals capital B little h, so we take the area of the base and multiply it by the distance between the two bases. So let's do some example problems here so this will make sense. Okay, so our first shape here is a rectangular prism. You'll notice that the shaded area at the bottom of the prism is the base. So the first thing it asked me to do is to find the surface area of this figure. So I need to figure out what capital P, capital B, and little h are so that we can use them in our formulas. Well, capital P stands for the perimeter of the base. So once again, the shaded part at the bottom is the base. So this is a rectangle, right? So if the right side over there, it says that side length is 5, that means the side opposite of it is also 5. Then we have 10 down here at the bottom. Opposite of that is 10. So capital P, once again, stands for perimeter of the base. So we would add 5 plus 5 plus 10 plus 10. We would get capital P is 30. So that's the area of that rectangular base down at the bottom. I'm sorry, the perimeter of that rectangular base down at the bottom. To figure out what capital B is, that stands for the area of the base. So all we would do, we know that the area of a rectangle is just base times height, so that would be 5 times 10. 5 times 10 would give me 50. And then little h stands for the distance between the two bases. All right, so we have a base down here at the bottom. I'm going to kind of color in right here. This is the other base up here at the top. So the distance between them over here, you'll see, is 2. So my h is 2. So now that we know all of these measurements, we can plug them into our equations. So for LA, we said that was capital P, little h. So in this case, that would be 30 times 2. So my lateral area is going to be 60. That would be in centimeters squared, because that's a two-dimensional measurement. Okay, for surface area, the formula is capital P little h plus 2 capital B. So we already found pH, right? We said that it was 60 just a second ago, so we can substitute that in for P times H. And then plus 2 times capital B, we found out a minute ago capital B was 50. When we plug that in, 2 times 50 is 100, plus 60 is 160. So 160 centimeters squared. All right, the last thing we need to do is find the volume. Well, we already found capital B was 50. The height h was 2. So for volume, the equation was capital B times little h. So all I have to do is multiply 50 times 2. When I do that, I will get 100. Now, volume is a three-dimensional measurement. So when I put my unit of measurement on here, I'm going to put it in centimeters cubed. All right, so here's my answers once again. 100 centimeters cubed for the volume. We said it was 160 centimeters squared for the surface area, 60 centimeters squared for the lateral area. Okay, for our next example, I've already written all the formulas out here for you. So once again, we have another rectangular prism. The shaded portion down at the bottom is the base. So the first thing we need to do is find out what capital P equals. Capital P means the perimeter of the base, so we have a 4 and a 4, so this is a square base actually. So that side would also be 4, that side would also be 4. If we add up all those 4s, 4 plus 4 plus 4 plus 4, we get 16 for the perimeter of the base. Alright, our height is the distance between the two bases, so that's over here on the side. It tells me that it is 6. So I simply multiply 16 times 6 to get my lateral surface area. When I do that, I get 96. So I'll come over here and put that in the blank. The answer is over here on the left. So 96 centimeters squared. Okay, for surface area of the rectangular prism, we already found the lateral surface area, so we can substitute that in right here. We said that was 96. Alright, plus 2 times capital B. Okay, capital B stands for the area of the base. So I would multiply the area, the sides of that square at the bottom, 4 times 4, and I would get 16. When I put all that in my calculator, 96 plus 2 times 16, you'll get 128. So my surface area, my total surface area, 128 centimeters squared. The last dimension they want me to find is volume. We said just a second ago capital B was 16 because 4 times 4 was 16, times h, the distance between the two bases, we said was 6. So 16 times 6 will give me my volume, which is 96. You'll notice here that the lateral area and the volume on this particular question were the same. That will not always be true. That's just a coincidence on this particular question. For our final example problem, we have a triangular prism. So the base on this particular shape, the two bases, are the two unique shapes, which are triangles in this case. Alright, so the first thing it wants me to find is the lateral area of this triangle. Now, these are right triangles. If I want to find the perimeter of the base of this triangle, I already see that one side is 5, one side is 12, but I don't know the hypotenuse, the side across from the right angle. This one is a Pythagorean triple. You could use Pythagorean theorem if you didn't know that, but this hypotenuse is going to be 13 centimeters right here. So when I figure out what the perimeter of the base is, to do that I would add 13 plus 12 plus 5. When I add those all up, I will get 30. Okay, my distance between the two bases over here is right here, that 10 centimeters. So my lateral surface area, or my lateral area of this triangular prism, 30 times 10, would be 300. Okay, once again, I'll put my answers over here on the left and make sure I put my units on there. So 300 centimeters squared. Okay, for surface area, we've already found the lateral area. We said was 300, so let's substitute that in. Okay, plus 2 times the area of the base. Now, this is what I don't know right now, is the area of this base. Remember, the base is a triangle. So I need to come over here to the side. I'm going to come up here to the top and find the area of this triangle. Okay, the area of the triangle is 1/2 base times height. Alright, well my base of that triangle is 12. So it's going to be 1/2 times 12. My height is 5. Okay, so 1/2 times 12 times 5. If I punch all that in, I will get 30. Okay, so that is the area of the base. That's my capital B that we just found, is 30. So put all that in your calculator. 300 plus 2 times 30 will give me 360. So surface area, 360 centimeters squared. Then the last dimension I want to find is volume. We already found capital B. That's where we came up here at the top and found the area of the triangle. We said it was 30. We know that h is the distance between the two bases. That would be 10. So 30 times 10 will be 300. Okay, once again, these two numbers match up. The lateral area and the volume are both 300 on this problem. That will not always be true. So make sure you don't just assume that the lateral area and the volume will always be the same. All right, that's it for the surface area and volume of prisms.